大家，但大家好像没有我答的没有我预期的好。So the multiple choice question. Question one. Question one. In chapter one, which is the correct form of Maxwell's equation for a source-free medium? Source-free medium. So the first answer is divergence E equal to rho over epsilon 0. A is divergence E equal to rho over epsilon 0. Curl B is mu 0 epsilon 0 partial E partial E. The second choice, divergence E equal to 0. Curl H equal to partial T partial E. The third choice, divergence E equal to 0. Curl E equal to partial minus partial B partial B, and the final choice, divergence D is mu 0 rho m. Curl E is mu 0 partial T partial H. So you see this is incorrect because rho m means magnetic charge density. There is no magnetic charge density, and this is incorrect. This is correct. Okay, in a source-free medium, this is Faraday's law. This is Gauss' law for the D field without electric charge, which means source-free. Okay. And how about this one? This one is incorrect because this one is correct. Only when epsilon is isotropic medium. In isotropic medium, this implies this, but in anisotropic medium, this is incorrect. So this is incorrect. Okay. And how about this one? This one is not source-free. Okay. In fact, yeah, this is not the source-free case. So the first answer, first question is C. And second, Pott statement correctly compares group velocity and phase velocity. A, group velocity is always faster than phase velocity. This is incorrect. B, group velocity is the velocity of energy transport, whereas phase velocity is the propagation velocity of wavefront. So B is correct. Okay. C, phase velocity directly equals the energy transport speed. This is incorrect because the energy transport speed is given by the group velocity. D, in a non-dispersive medium, the group velocity is slower than the phase velocity. This is not certain. Okay, this is not certain. For dispersive medium, there's no definite result about the relation between group velocity and the phase velocity. Okay, so the second question, the answer is B. How about the third question? In a uniaxial crystal, which of the following is correct? In a actual crystal, which of the following is correct? A. O and E rays have the same refractive index. This is incorrect. B. The refractive index of the ordinary ray is direction independent, whereas that of the extraordinary ray depends on direction. Okay, this is correct. C. The extraordinary ray is always slower than the ordinary ray. This is incorrect. D. Both rays always share the same polarization state. This is incorrect. The fourth question. If a land wave enters an anisotropic crystal and its electric field is aligned with one of the principal axes of the index ellipsoid, what will happen? 就是说你现在是电场刚好对到某个主轴的时候会发生什么事？A. It always split into two rays. No. 你现在如果已经对到一个主轴，不会变成两个 ray. This is incorrect. B. It propagates as a single ray. This is correct. It propagates as a single ray. C. It is immediately absorbed. 这是错的wrong. D. The electric field must rotate into another direction. 这也是错的This is incorrect. 第五题Let E and B be the complex electric and magnetic field vectors of a monochromatic electromagnetic wave. The real part of the complex conjugate of quantity Z are denoted as symbol real Z and Z star, respectively. What is the correct expression for the time average Poynting vector? The correct result is D. This real part each cross H star. We have learned this result in chapter 1. And the sixth question. A plane EM wave propagates in a biaxial crystal. Let E, H, D, B, and K denote the electric field, magnetic field, the displacement field, the magnetic induction field, and the wave vector, respectively. If the propagation direction is arbitrary, which statement is in general incorrect? A. K dot D is equal to 0. This is correct, so we do not choose the correct answer. We choose the incorrect answer. The increase C E dot H equal to 0. This is correct. E dot H equal to 0. Also correct for the answer D. So the incorrect answer is B. B says that K cross real part of E cross H star equal to 0. This is the direction of Poynting vector. And in general, in anisotropic medium, Poynting vector represent the propagation direction of energy, and the K represents the propagation direction of phase. And the phase velocity and the energy velocity in general are different. So K cross S in general is not equal to 0. So this is incorrect. So we choose B. So the answer of these questions are C, B, B, D, B. Okay. 好，然后我们现在进入到这个第7题。Problem 7. Okay, the A, you are given the complex representation of the polarization as -I. To find complex number representation of the polarization that is orthogonal to this one. Okay. Then we can use this to construct J vector as okay. Once you have a chi, you can write the corresponding Jones vector like this. This coefficient is not very important when we consider the orthogonality. Okay. So we now want to find J prime, which is perpendicular orthogonal to J. So assume J prime to be this, then orthogonality means J dagger times J prime equal to 0. So this means that 1 chi star times 1 chi prime equal to 0. So this is 1 plus chi star chi prime equal to 0. So this means that chi prime is equal to minus 1 over chi star. Okay. So if say chi is equal to exponential I delta sine theta over cosine sine over cosine sine say. So this means that minus 1 exponential minus I delta, okay, chi absolute value. This is the absolute value of chi. This is absolute value of chi times the base. Okay? And here we have a minus sign. So this means that minus, okay, the phase factor is the same as the original chi. Okay? The phase factor is the same. Okay? You can also write this as which means you can write this as this. Okay. So for this, we have simply the result is minus I star minus I. Okay, so minus 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 I star minus。好，看一下，这个对不对？解。对，好，然后原来是 minus I 了，这边是 star。Okay. So this means minus 1 over I, which is I. The answer is I. So the answer for the A item is I. And for B, the answer is this. Chi prime is equal to minus 1 over chi star. Okay.
write it like this. Minus chi over 开的绝对值。我看一下对不对？对 ，OK。好 ，so this is the answer for B part B. Okay. This one. This one. 好。好，然后再看这个第8题。In this problem, I gave you normal surface of EM then waves propagating in a uniaxial crystal. Uniaxial crystal. So in uniaxial crystal, you have the so-called O wave and the E wave. So A for O wave or O ray. This is z-axis or c-axis. Okay, x, y, and I give you the propagation direction of the k vector. S is this 45 degree. Okay, S is in the YZ plane. This S is small s parallel to the k vector. Okay. And we know that for O ray, the D vector and the E vector are both perpendicular to the k vector and the optical axis. So it means that E and D are along the x-axis. So E, D are parallel to the x-axis. Okay. And how about the H? So H is parallel to K cross E. Okay. And the K is in the YZ plane. And the X, K cross S in this direction. And this, okay, here, this. So it just reverse the Y sign. So H is parallel to this. Okay, or you can write this as 1, 0, 0, and you can write this as 0, minus 1, 1. Okay, then how about the pointing vector? Pointing vector is parallel to E cross H. So here this is E 其实可能要反过来抱歉，我把这个反过来 H 这边多一个负号。好，这边正负号你写反的我都不管就是只要同一条线这样都 OK 就是这个就变成是OK 然后 E cross H 结果它还是平行于小写的 S 就是它就会平行于跟化分之一的 Y 加 Z 就是这个这样子这是 O ray 的情况啊。好，然后 B for E wave or E ray。那对于这个 E ray 的话呢 ，D vector 还是要垂直于 K vector， 但是呢，它又要垂直于这个 O ray 的电场，所以它其实是这个方向。So the D vector parallel to minus y plus z. Okay. And so this is parallel to this one. And how about E? E is epsilon inverse times B. Okay. And this is O E times 0, 1 minus 1. Okay. So this means that we have this proportional to 这个的话呢，因为 epsilon O 是等于 epsilon 0乘上 NO square, okay? And epsilon E is equal to epsilon 0 times NE square. So we can also write this as 1 over NO square minus 1 over NE square. Okay. Or you can write this as NE square minus NO square. Okay. And H vector, 这个是 E vector. And H vector now is along the x-axis because H must perpendicular to D and S. Okay, so H is parallel to the x-axis 1, 0, 0. Okay, and then finally the pointing vector. Pointing vector is parallel to E cross H. Okay, so now E is this one. E vector is this one. E vector is this one. So S vector, H is X, S vector is parallel to Y cross X give us minus Z. Minus Z cross X give us minus Y. So this means y over ne squared plus z over no squared. So you can write that pointing vector is parallel to, say, 0, 1 over ne squared, 1 over no squared, or 0 no squared, ne squared. Okay. 你们有些人那个正负号都搞不对，会有一些正负号的问题，然后另外还有一些人很奸诈，就是他对一类跟欧类都写一样的答案，然后呢，但是我还是很好心的给你们一个对，或者是他写反了，我把它倒过来，给他一点分数，所以 anyway 就这些东西究竟该怎么对，你们应该要自己搞清楚，so you 好，第9题。其实我真的考得太基本了，是不是考太简单你们不会，要考难一点。第9题，好 ，The dielectric permittivity tensor of a crystal in the lab XYZ frame is given by epsilon is equal to epsilon 0 times A B 0 B A 0 0 0 C 这只是公数嘛，so what is its principal value, eigenvalue? The eigenvalue you just try to diagonalize it, then you get this epsilon 0 times A plus B, epsilon 0 times A minus B, epsilon 0 times C 你们有的同学没有写在 epsilon 0，我还是给你对的然后呢，这是 A 小题，那 B 小题呢，它所对应到的 eigenvector 呢，这 eigenvector 呢就会变成是这个 1 1 0。OK， 其实这边是要除以等号这除不除我都算对另外一个是 1 minus 1 0然后最后一个其实是 0 0 1有的同学只写2个答案那我还是尽量挑你对的给你So this is the answer to question 9那第10题的话呢，第10题的我的打分数的标准是这样的，就是你 A 小题你只要写出忽略反射，我就给你全对第10题的 A 小题你如果只是把这个公式照抄一遍，我就划掉因为那些东西反正你只是抄公式，你不知道你在干嘛那总之你一定要讲出一个关键，我才给你分，就是 no reflection， 或者是 ignore reflection。就有相关的这个，我大概就给你全对。如果沾到一点边，我可能会给你一点分数。但是如果你只是把数学公式套来套去，说这个就是一个 unitary， 那个我就不给你对还有的同学把那个 unitary 理解成单位矩阵，不是单位矩阵，那叫标正矩阵unitary。这个叫做，它的意思是， 好，所以这一题我的改分标准是这样，一定要有You must have some keyword related to the concept no reflection, ignore reflection, something like that. Then I can give you the point. 那 B 的话呢 ？B 的答案其实是这样它是一片这样，比如说 x 然后 wave play 的慢轴夹30度，然后最后是这个这样好，那总之就是说我一开始一单位的 I 等于1，对不对？然后呢，通过这边之后会变成1/2，然后通过，因为这边会有一个偏振倍率出来，so when the light unpolarized light penetrates through the first polarizer, its strength becomes 1/2, and then this part gives you 3/4 transmitters, and then so finally I prime is equal to 1/2 times this and 3/8。好，所以最后会变成是0.37或者3/3。好，那所以要有这个我才给对其他的都没有就只有第10题我标准比较严格一点其他的其实都改得很松改得好，所以这是这个结果那我不知道好像有看到同学是完全没写选择题的，我觉得蛮不可思议就是怎么可能就竟然完全没有写选择题好，那刚刚还有同学没有拿到考卷的，我再念一下黄子琪有在吗？这个KDP 晶体的这个新的主轴怎么找呢？那个还没有讲完，我们现在来把它讲完。So last time we discussed about the KDP crystal when we apply electric field along the x-axis. Okay, when we consider the KDP crystal, and we apply electric field along the x direction, then according to the table, we get this modified index absorption x squared over NO squared plus y squared over NO squared plus z squared over NE squared plus 2 y z r 4 1 e x equal to 0. So now you see that we mix the y and the z. We have this cross term to mix y and z, and the coefficient of y squared and z squared are not the same. So it is not as easy as before that we can simply rotate 45 degrees to decouple this equation. Now we need to rotate some angle, but we don't know what angle it is. So we need to solve for this angle. to decouple y and z term. Okay. So now we assume we rotate around the x-axis by angle theta. Okay. And this means that we can write yz as linear combination of y prime and z prime. Here, r minus theta is cosine theta minus sine theta, sine theta, cosine theta times y prime z prime. So we have y equal to y prime cosine theta minus z prime sine theta. And z is equal to y prime sine theta plus z prime cosine theta. Okay. So now we have y squared equal to y prime squared cosine squared theta plus z prime squared sine squared theta minus 2 y prime z prime sine theta cosine theta. And for z we have z prime y prime squared sine squared theta plus z prime squared cosine squared theta plus 2 y prime z prime sine theta cosine theta. And yz, for yz is equal to y prime squared minus z prime squared times sine theta cosine theta. And yz prime, y prime z prime times cosine squared theta minus sine squared theta. 好，那我们这些现在第一个任务是什么呢？我们要解耦合啊，就是你只要出现 cross term 那些，就要让它消失，怎么消失呢？啊，我们把它带进原来那个式子。好 ，we substitute this result into the original equation. This equation. We substitute this result into this equation, and then first we have x squared over no squared, and then we have 1 over no squared times y squared. Now y squared is y prime squared cosine squared theta plus z prime squared sine squared theta minus 2 y prime z prime sine theta cosine theta, okay, plus 1 over ne squared times 我现在把这个写前面 z prime square cosine square theta plus y prime square sine square theta。我现在没有必要，等一下，我还是直接照常。y prime square sine square theta plus z prime square cosine square theta plus 2y prime z prime sine theta cosine. Okay, and then we have plus 2r4 1ex times this cross term y prime square minus z prime square times sine theta cosine theta plus y prime z prime cosine square theta minus sine square theta. Wait. 好，那我们现在这个东西加起来等于1，加起来好 ，so we now collect the cross terms. We now collect the cross term of this form. Okay? The coefficient of y prime z prime. We have minus 1 over no square times 2 sine theta cosine theta give us sine 2 theta. So minus sine 2 theta times y prime z prime times 1 over no square. So we have minus 1 over no square times sine 2 theta. Okay. So similarly, here we have 1 over ne squared times sine 2 theta. And here, this is just cosine 2 theta. Cosine 2 theta is equal to cosine square minus sine square. Cosine square theta minus sine square theta is equal to cosine 2 theta. So we have 2r4 1ex times cosine 2 theta. Okay? So we require this equal to be 0, because only then can we decouple the equation. 就是我们现在要求说我们要选到一个对应的 theta， 使得呢 y prime z prime 的系数是0，所以这个就是我们所要求的 y prime z prime 的系数要等于0的条件。This is the condition that makes the coefficient of y prime z prime equal to 0。好，那我们把这个条件用进去会得到什么？ So this condition means that 2 R41 EX cosine 2 theta is equal to 1 over NO squared minus 1 over NE squared times sine 2 theta. So this means that tangent 2 theta, which is equal to sine 2 theta over cosine 2 theta, is equal to this 2R41 EX over 1 over NO squared minus 1 over NE squared. 好，这个就是课本上的那个条件啊。This is equation 7.2-15. So we must choose the rotation angle theta to be equal to 1/2 arctangent this if we choose the angle correct, then we will get the final result only contains this square term without extra cross term. Okay. 好，如果我们选的角度如果正确的话，就选到这个角度的时候，剩下都会是平方向，就不会有那种交叉项。好，那现在呢，我们把这个带进去之后呢，我们现在已经没有交叉项了，对不对？把这个 theta 选对了之后，带进来之后就没有交叉项了。So after we substitute this correct angle into our equation, then the cross terms disappear. So finally we have this, and this. Okay, we have this equation. So this means that we have x squared over NO squared plus 好，这边的话剩下的是1 over NO cosine squared theta over NO squared plus sine square theta over NE squared plus 2R41 EX times y prime squared, okay, plus sine square theta over NO squared plus cosine square theta over NE squared minus 2抱歉，这边有个地方写错 ，sorry， 这边是刚刚那个是 2R41 EX times sin theta cosine theta。y prime squared plus sine squared theta over NO squared plus cosine squared theta over NE squared minus 2R41 EX sine theta cosine theta times z prime squared equal to 1. Okay. 好，那我们现在想要把它改的简洁一点啊，因为这个看起来还是太多想太啰嗦了啊。This expression is correct, but it looks too complicated. We can try to simplify it. Okay, because originally we have the coefficient before y prime 1 over NO squared. Okay, and the coefficient before z prime originally we have 1 over NE squared. And the EO effect is a very small effect. It just gives a very small correction to the original coefficient. So we can rewrite all these quantities inside the bracket so that we can write it as 1 over NO squared plus some small correction. Okay, so we try to do this now. So we see that this bracket 我把这个叫1号，叫2号。Number 1 bracket can be written as 1 over NO squared minus 1 over NO squared minus 1 over NE squared times sine squared theta plus 2 R41 EX sine theta cosine theta. OK， 这边是因为你看啊，1减掉 sin 平方就是 cosine 平方啊，然后负得正 sin 平方就是原来的 sin 啊，后面这个没有变啊。So now we can rewrite this part according to this result. Okay. 1 over NO squared minus 1 over NE squared can be written as 2 R41 EX over tangent to theta. So we can substitute this into this equation to get 1 over NO squared minus this times R41 EX, okay, plus 2 sine 2 sine theta cosine theta R41 EX. Okay. In fact, this we can write this as plus R41 EX. 这样讲好了。这个呢 tangent 2 theta 可以写成 sin cosine 这是 sin 啊 cosine 2 theta 这是 sin 2 theta， 所以这个其实可以写成这样 2 sin square theta cosine 2 theta over sine 2 theta. OK， 这边我们就是这样好了。 这里跟这里都有 sin， 我们先提出一个 sin。Sorry。We can factor out r for 1 ex and 1 sin theta factor. And then this becomes, we can write tangent as sine over cosine. So this becomes minus 2. 这边两个2，可以把2也提出来。factor out 2。这边剩下一个 sin sin theta cosine 2 theta sin 2 theta. Okay? And this part we have cosine theta. 2 r41 ex sin theta times this. Okay. 好，那我为什么要这么做呢？因为你看啊。So this means the first bracket is equal to 1 over no squared plus 2r41 ex times sine theta over sine 2 theta times sine 2 theta cosine theta minus sine cosine 2 theta sine theta. And this is nothing but sine theta, because 2 minus 1. So now we have 1 over no squared plus 2r41 ex times sine squared theta. Okay, and here sine 2 theta means 2 sine theta cosine theta. So we can cancel 1 sine theta and cancel this 2. So finally we have 1 over no squared plus r41 ex sine over cosine tangent theta. 好，那对于第二个呢？第二个括号呢，其实我们可以有一个很简单的处理方式呢，完全不需要再重新推一遍。怎么做呢？你看啊 ，You can observe that 1 plus 2 is equal to 1 over no squared plus 1 over ne squared. Okay, so this means that bracket 2 is just equal to 1 over ne squared minus r41 ex tangent theta. Okay. So finally we have this expression. X squared over no squared plus 1 over NO squared plus R41 dx tangent y prime plus 1 over NE squared plus R41 dx minus tangent z prime squared equal to 1. Okay. So we can identify this as x squared over nx squared plus y prime squared over ny squared, ny prime squared plus z prime squared over nz prime squared equal to 1. So nx is just no nx or nx prime. X is equal to x prime. And ny prime is equal to no minus 1/2 no cubed times R41 dx tangent cubed. I have already explained this, why there is 1/2 no cubed times the variation of this small discrepancy from the 1 over no squared. And nz prime is equal to ne. The minus sign times minus sign gives us plus sign. 1/2 ne cubed R41 dx。这个就是最后的结果。These are the final result for this case. 好，那我们接下来看下一个例子。Next example, 7.2.2. Okay. The yield effect. Of 醚酸锂. The symmetry of this crystal is 3M. So you check the table to find the R matrix for symmetry 3M. We get this form: 0, 0, 0, 0, R4, 5, 1, minus R2, 2, R5, 1. 0, 0, 0, 0, 0, minus R2, 2, R2, 2, 0, R1, 3, R1, 3, R3, 3, OK， 好，那现在我说过，就是我们可以这样子记啊，比如说你把这边写 EX， 这边写 EY。这边写 EZ， 然后呢这边写 x 平方 y 平方 z 平方 2yz 2zx 2xy。 So you can just write down this xyz and exeyz to see the terms that you need to add to the original index ellipsoid. So now we apply the electric field along the z-axis. We now choose E to be EZ times this, which means EX, EY are both equal to 0. We can write EC as E. So this means now we have this 0, 0, E. So what is the new index ellipsoid? So the correction appears here. We have Ry 3e times x squared and R13e times y squared and R33e times z squared. So the index ellipsoid now becomes this. 1 over NO squared plus R13E times x squared plus 1 over NO squared plus, here we also have R13E times y squared. And then 1 over NE squared plus R33E times E squared. Okay, this is the new index ellipsoid under the influence of the applied electric field. Okay, so now we see that nx prime or nx now becomes no minus 1/2 no cubed R13 times E. And ny is no minus 1/2 no cubed R13. And nc is equal to ne minus 1/2 ne cubed times R33 times E. Okay. So we see that if we calculate the difference between NZ and NY, we see the difference is NE minus NO plus minus 1/2 NE cubed R33 minus NO cubed R13 times E. So the difference between NZ and NY contains two parts. The first part, this is fixed. Okay, this value is fixed. However, we can have a modification linearly dependent on the E field. Okay, so this means that we can use we have a crystal, and if we apply electric field, we can tune the phase difference between the two axes, so we can make some kind of tunable wave plate。就是我们可以做所谓的 modulation。那我们在正式去解释 modulation 之前呢，我先跳到倒数第二节去讲 projecting 的current effect。Before I further explore the modulation by means of EO effect, now we discuss the projected EO effect. Section 7.5 project EO effect. For projecting EO effect, we have the S matrix Sijkl, which can be renamed as SAB. Here A contains 6 independent indices, and B corresponds to 6 independent indexes. Then SAB is a 6 by 6 matrix. Okay. So this means that we now have S11 to S16, S11 to S61, S11 to S66. Now we have EX squared, EY squared, EZ squared, 2 EY EZ, 2 EZ EX, 2 EX EY. Okay. And here we have X squared, Y squared, Z squared, 2YZ, 2ZX, 2XY. So once we have this as coefficients, curve effect can be written as one over nx squared plus S11 times S11 times EX squared. Okay. This one means x squared. This one means EX squared. Okay. And S12 times EY squared. This one means x squared, and this 2 means y squared. S13 EZ squared plus 2. Do not forget this factor 2. 2 S14 EY EZ. Okay. This one this one indicates x squared, and this 4 corresponds to 2yz, and then plus 2s1 5 e z ex plus 2s1 6 e x e y。y square 是类似的，z square 是类似的。那我们现在来看一个2yz。Here, 2yz. This corresponds to S4, 1. 4 means 2yz, and this 1 means ex squared. Plus S4, 2, ey squared. Plus S4, 3, ez squared. Plus 2s4, 4 e y e z。这边的这个第一个 4 当然是对应到这个 2yz， 那第二个 4 呢，对应到 ey ez， 但不要忘记这边有 2。Do not forget this factor 2. Okay. And similarly, we have 2, 4, 2s4, 5 times ez ex plus 2s4, 6 ex ey. And similarly for 2zx, 2xy. This is equal to 1. 看起来好像很复杂，但是实际上呢，它有很多的这个 element 样或者是零所以实际操作起来并没有真的那么复杂。好，那我们来看一下这个具体的例子。Now let's see some examples. The first example, 7.5-1. Curl EO effect in isotropic medium. For isotropic medium. For isotropic medium, we have the S matrix of this form. S11, S12, S12. This one. along the z-axis. We choose E to be along the z-axis. Ex is equal to Ey equal to 0. So this means that here 0, 0 E squared. 0, 0, 0. If x squared, y squared, z squared, 2yz, 2zx, 2xy. Okay. So the correction are contributed by distance. For isotropic medium, we have nx, ny, nz equal to the same n. So this means that we have 1 over n squared plus the correction s1, 2 times e squared. This times x squared plus this times y squared plus this times z squared equals 1. So we see that now we have these two coefficients are the same, so we can identify them as 1 over n whole squared. And this can be identified as ne, 1 over ne squared. So we see that no is n minus 1/2 n cubed times s1 2 e squared, and ne is equal to n minus 1/2 n cubed s1 e squared. So now this isotropic medium becomes an uniaxial crystal whose difference between Ne and NO is given as 1 over 1/2 n cubed times s1 2 minus s11 e squared. 好，那我们这边先下课10分，好，现在先休息。Yeah, so once we apply the electric field, the originally isotropic medium becomes uniaxial crystal, and the difference of the refractive index between this the O and the E is given by this, which is proportional to the square of the electric field. And if you observe it clearly, you see that here, this part is in fact as 4. Okay? So this means that we can write the difference Ne minus No as we can write Ne minus No as minus No cubed times S4 times E squared. Okay. And sometimes this can be written as K times lambda times E squared. Here this K is related to S44 by this relation. Okay. Here K is called Kerr constant. You can check the current constants for different materials in table 7.6 你可以在这个 table 7.6里面找到一些材料的 current constant 然后呢，你有了 current constant， lambda 就是波长然后你用这个你用 current constant 去乘上 lambda， 就得到这边需要的系数去乘上这个1平方，就会给出这个 Ne 减能功。好，那我们再来看第二个例子The second example.这个例子呢是 example EO effect碳酸废。那边它主要讲到两个重点，第一个是跟温度有关，就是如果是 T 小于 Tc，if the temperature is lower than critical temperature, this material belongs to this symmetry. And once we go to the temperature higher than crystal temperature, the symmetry becomes M3M. Okay. And for this, we have linear EO effect. And for this, we have quadratic EO effect. 就是说，如果是温度低于一个所谓的临界温度，Tc是 critical temperature。就好像从冰变成水我们会有一个温度是融化点，然后或者从铁磁变成非铁磁，或非铁磁变成铁磁，也会有一个临界温度叫 critical temperature。然后在临界温度以下跟临界温度以上的symmetry是不一样的，就是说越低温的时候呢，它会越规则，越规则其实它的对称性就会是更受限 好，然后呢，这个越不规则的时候反而越均匀啊，就是温度高的时候呢，会变成另外一种对称性。那不同对称性你去查表的时候就会有不同的结果啊。然后所以我们现在主要是在看的是 quadratic。Now we want to see what's the effect, what's the quadratic EO effect, okay, above the critical temperature. Okay, so you can check the table to find M3M symmetry. For M3M symmetry, the quadratic EO effect are determined by S of this form. 你会发现这个跟刚刚形式几乎一样，只是现在呢 S44跟 S1、S12没有直接关系了。好，刚刚是 S44跟 S11、S12的差直接证明。Okay, the S matrix looks like this. And then, if we apply the electric field, we apply it along the 45-degree between y and z axis. So this means that E x is equal to 0 and EY is equal to DC is equal to 1 over square root 2. Okay. Sorry. E.好，那我们就把这个带进来。So now we have this x squared, y squared, z squared. Okay, and 2yz, 2zx, 2xy. Ex is equal to 0. Ey, here we have 1/2 e squared. 1/2 e squared. To yz, 2ey ez is equal to 2 times 1 over 2 e squared, which is equal to e squared. So now here we have e squared. 2zx, no x. 2xy, no x. Okay. So now we have this term and this 3 terms. Okay. 好，这边有一个课本没有特别说清楚的，就是在原来还没有加电场的时候，这 crystal 的这 crystal 的这个 n 并没有 n1 跟 no 的差别，就是只有一个 n 啊，就是它像是 isotropic medium 啊。那所以现在修正之后会长成什么样子？这样。X squared times 1 over NO squared plus看我哪里写错了。y 的是z y z 等一下，好，抱歉，我这里写错了啊，我这里是 x y 不是 y z。Sorry, x, y, so here 1/2 e squared， 这边没有，这个才对，这样子。然后，那这个就不是这个了，就会是这个。这边。对，好，好，这样就对了。So this term 1/2 e squared times s1. And this term 1/2 e squared times s1. Plus 1/2 s12 e squared plus 1/2 s11 e squared. Here we have this 1/2 e squared times s12 plus s12. 2s12 times 1/2. So this is 1 over n squared plus s12 times e squared plus e squared times 2xy times s4 for 2xy s4 e squared equal to what? Okay. And you see that now these two coefficients are the same. So we can use the same trick just like we did before in the KDP case, linear KDP case. So we can rotate our coordinate axis by 45 degrees to decouple this result. And finally, we will find that this becomes x prime square times 1 over n squared plus 1/2 S11 plus S12 e squared plus S44.这边究竟加还是减的话，我需要再回忆一下啊。就说，我们可以先把这个先整理一下，就说这边的话，这个系数就乘上了 x 平方加 y 平方。好 ，so x squared plus y squared times the same coefficient plus z squared times 1 over n squared plus S1 2 e squared plus 2 xy S44 times e squared equal to 1. Okay, and then we can try to combine x and y. We can write x prime to be 1 over square root 2. 反过来写 x 1 over square root 2 x prime minus y prime. Okay, and y is equal to 1 over square root 2 x prime plus y prime. Okay. And after rotation, the sum of the square term is the same as before. Okay. This is the same. And 2xy now becomes x prime squared minus y prime squared. So this means that we have x prime squared plus y prime squared times the same coefficient 1 over n squared plus 1/2 S11 plus S12 e squared, okay, plus z squared times 1 over n squared plus S12 e squared, and plus x prime squared minus y prime squared times S44 times e squared equal to 1. Okay. So finally we have this uh, 1 over n squared plus 1/2 S11 plus S12 e squared plus S44 e squared. This times x prime squared, okay, plus 1 over n squared plus 1/2 S11 plus S12 times e squared minus S44 e squared times y prime squared plus 1 over n squared plus S12 e squared times z squared is equal to 1. Okay, so this is this can be identified as x prime squared over n x prime squared plus y prime squared over n y prime squared plus z squared over n z squared equal to 1. Okay. So this means that So this means 1 over nx prime squared is equal to 1 over n squared plus 1 half S11 plus S12 e squared plus S44 e squared. Okay, and 1 over ny prime squared is equal to 1 over n squared plus 1 half S11 plus S12 e squared minus S44 e squared, and 1 over nz prime squared is equal to 1 over n squared plus S12 e squared. So, according to this result, we find nx prime is n minus 1 half n cubed times this correction. Okay, so this includes this term S44 e squared plus 1 half S11 S1 e squared. Okay, so this gives us n minus 1 half n cubed S44 e squared minus 1/4 n cubed times S11 plus S12 e squared. Okay. And similarly, for the y and z, for ny prime is equal to n minus 1. Now this becomes plus because here is a plus sign, here is a minus sign. So now this becomes plus 1 half n cubed S44 e squared, and minus this times S11 plus S12 e squared, and nz prime is n minus 1 half n cubed S12 e squared。好，那这个就是745的这个第二个例子。好，那我们现在再回过头去，回到前面我们略过还没讲部分，好，我们要讲这个回到线性的EO effect 的 modulation 的部分，好，我们现在退回到743。So now we talk about the EO modulation. Okay. We see in the KDP case of the 1 as a linear EO effect. The first example, 7.2.1, in the KBT example, when we apply the electric field along the z direction, and we see that we have this x squared plus y squared and o squared z squared over n e squared plus 2r63 e z x y equal to 1. Then we can rotate the coordinate axis 45 degrees with respect to the z-axis. Then we find this x squared over n x prime, x prime squared over n x prime squared, y prime and y prime plus z squared over n z squared equal to 1. Okay, and then the difference the nx now becomes 我们这边可以直接把这个不用叫 prime， 就直接叫 nx 等一下让我看看这个对还是叫 nx prime 好。The nx prime is given by no minus 1/2 n o cubed are 63 easy, and the ny prime is equal to no plus 1/2 n o cubed are 63 easy. So we see that the difference between nx prime and ny prime is so the difference between ny prime and nx prime is no cubed are 63 easy. Okay. And this is a tunable result. Okay. Once we have this difference, we can calculate the corresponding gamma if we now use this crystal to construct to make a wave plate. Okay, and we have one axis corresponding to x prime, the other axis corresponding to y prime. Then we can treat x prime as the slow axis, y prime as slow axis, and x prime as the fast axis. Okay. 这边是反过来。好 We can treat y prime as slow axis and z prime as the x prime as the fast axis, slow, fast, and we can use this as a wave plate. The corresponding gamma, the phase retardation of this wave plate, is given by omega over c times the ny prime minus nx prime times the thickness of the wave plate. And if we substitute this result into this equation. We know that omega over c can be written as 2 pi over lambda. Okay, the wave number in the free space. So this times NO cube are 3 times EZ times D. You can add a battery here, okay, and the voltage difference between the two surfaces is given by EZ times D. This is the V, the voltage difference 就两边的这个电压的差电位差那电位差，这个电位差就会对应到这个伽马。Okay, so this voltage difference is proportional to this gamma. So we can apply a voltage to create this phase retardation effect. Okay, and then we can just use this as our original wave plane to control the propagation of light. Okay. Now we see if we apply voltage difference between the two surfaces of the crystal and we put one polarizer and one analyzer, then we can use this device to control the transmittance of light.我们这边还可以再放一块非 EO 的这种 wave plane。原因是什么啊？因为我们这边虽然说加电压可以产生 retardation， 但是呢，有时候这个算出来就是电压要加得很高那我们的目的其实不是电，而是光。我们的目的是要调控这个 retardation，OK，所以我们可以一部分用真正的 wave plane， 然后一部分用加电压的方式，那这部分用加电压，那这部分就用原来的 wave plane，so we can this total retardation can come from two different sources. The first may comes from the EO effect. The second contribution may come from a real wave plane. And then we have this second polarizer as the analyzer. P, Y, P, X. And usually we choose this wave plane to be the quarter wave plane. The reason will be clear later. Okay. 那所以我们现在呢就可以怎么写呢？这样子啊。我们先看这一个哈，先看原来就是完全使用 EO effect 来制造 retardation。If we use an EO crystal and without this additional wave plate, then how much what's the value of V that corresponds to retardation equal to pi? Suppose the voltage is denoted as V pi, and V pi corresponds to gamma equal to pi. Then we have V pi equal to lambda over 2 pi, V pi times 2 pi over lambda times NO cubed times R63 equal to pi. Okay, and according to this, we can calculate V pi is given by lambda over 2 NO cubed R63. And then you can use the value of NO and R63 and the lambda to calculate. For example, lambda is equal to this. And the final result we find is about 9.3 kV, which is a high voltage. Okay. Only when we apply this high voltage can we have a retardation equal to pi. Okay. So if our purpose is the retardation, then a part of the retardation can be provided by another wave plane. Okay. So here we use another wave plane here. So once we know the total retardation, then the transmittance can be calculated. The translation now becomes sine square half gamma. Okay. 这个很容易算出来啊，这很容易算出来。就因为呢 ，originally we have y polarization 等一下哦，原来不是 y， 应该是 x。OK x， sorry， this is x。This is y， 好，这个 x y 的摆置方式跟前面不一样，颠倒，好，你把它想象成 x y 的角色颠倒，好。So originally, after passing through this polarizer, we get an x polarized line. Okay. And since now we have this is y prime, this is x prime, and this is x. So now x can be written as this. Okay. And So if I use x prime, y prime as our basis, if we denote x prime, y prime as our basis, then originally we have x equal to 1, 1. Okay. Then after penetration through this crystal, this becomes B prime. Originally B is equal to this, and B prime is becomes this.这边究竟谁是负谁是正，其实没有很重要。好，这边写成负，这边写成正也没差。好，最后的结果其实是一样。好 ，So 好，我们现在呢，最后得到这个东西的时候啊，我们就我们现在是把 x prime 当成 fast， 然后 y prime 当成 slow， 好，所以总之就是我们一个是增加了2分之 i 伽马，另外一个是 exponential 的负2分之 i 伽马，好，然后这个东西呢就会变成是这个总之最后呢。你最后就可以去算这个 transmittance， 好，那这个 transmittance 的话呢，因为我们现在 finally 的这个东西啊，其实就是根号2分之1等于x prime exponential I half gamma plus y prime exponential minus I half gamma，OK， 好，那。但是我们最后这个会有一个 y polarizer， 对，所以你就 y 去 dot v prime， 所以得到什么呢 ？And this becomes this， 好，那现在的 y 呢是朝这里啊 ，y 我们现在就是 x prime 是 y prime， 只是 y 朝这里。y 朝这里 ，x 朝这里，所以 y 跟 y prime 的夹角呢是45度，好，然后 x prime 跟 y 的夹角是135度。So y dot x prime， y dot x prime， the angle between y and x prime is 135 degrees. So this gives us minus this exponential I half gamma. And the angle between y prime and y is 45 degrees. So this gives us 1 over square root 2 exponential minus this. So this sign difference gives us the final sign factor. 这边变成是负2分之1，然后1的 I half gamma minus 1的负 I half gamma. Okay. So the difference is 2 I sine half gamma, and the result is minus I sine half gamma. Okay. So the transmittance is Vy prime over Vx squared of the absolute value. And this becomes sine squared half gamma. And since gamma is proportional to V, so gamma over pi is equal to V over d pi. V over d pi. So we can write gamma as pi times V over V pi. Okay? So this tells us that T this can be written as sine squared half gamma. So half pi V over V pi. Okay? This is formula 7.3-6。就是你现在会有一个跟 v 成正比，好，那这个呢，你可以进一步写成这样，写成1/2的1减 cosine 伽马，好，然后如果你把图画出来的话，它就会长成，再给我1分钟，好 If you plot the result, it looks like this. Okay. And if you insert a quadratic, a quarter wave plate here, it provides half v time. It provides a gamma, which corresponds to half v pi, and you can operate at this region because this region is linear. So if you send a signal like this, you get an output of transmittance like this. Okay. So you can modulate. Here you can modulate the voltage. Then you find the modulation result of the light. 好，那下一次我们再仔细讲。好，那有分2种 modulation， 一个叫amplitude modulation， 一个叫 phase modulation。好，那我们目前讲的这个是 amplitude modulation， 下一次还会讲 phase modulation。好，我们今天讲到这里。